Chain rule. Chaining it up. Yeah. I agree with both statements. All right. So whenever you take the derivative of anything, you have to actually take the derivative of everything by the end. So with chain rule, we take the derivative of the outside and end up taking the derivative of the inside after. So an example would be, bless you, find f prime of x if f of x equals square root x squared plus 1. Whenever you have the square root of anything, you guys, always, always, always turn it to an exponential fraction and then do the derivative of it. So the first thing I'm going to do is change this to x squared plus 1 all to the half. Because your index drops underneath your exponent. Remember? We've done this before. We just had, bless you, square root x. So, my goodness. You have x squared plus 1 to the half. So, before we were able to do this, because we would just have like x to the half, so we take the half, we drop it in front, x, and then we drop the exponent by 1, and it would be to the negative a half, right? But now we have something inside the brackets. So the first thing we do is just treat this bracket, what's inside here, just like it's an x. So we do the derivative of the outside first. So half drops in front. Now if this was just an x, we'd write it just as an x, right? So we're just going to write it as x squared plus 1. That does not change. And then we drop this by 1. So a half minus 1 is negative a half. So if this was x squared plus 1 was just an x, we'd be done, right? But in the end, we have to take the derivative of everything. Everything needs to be differentiated. And right now, we've differentiated the exponent on the outside, or we differentiated the radical, but we haven't differentiated what's inside the brackets. So chain rule says we take the derivative of the bracket, so x squared plus 1, we took the derivative of the bracket, and then we take times that by the derivative of what's inside the brackets. So we times this by the derivative of what's inside the brackets. So what we're left with is x squared plus 1. The derivative of x squared is 2x, and the derivative of 1 is nothing. Then what you need to do is just take this 2x and have it join the front. So what I always do is this joins the front number. So a half times 2x. And then x squared plus 1 to the negative a half. A lot of people try and like distribute into that. This whole thing is to the negative a half. The only way we're going to be able to simplify that at all is if we can take an x squared plus 1 to the negative half out later on when we have more, when we do product rule, quotient rule. But right now we can't. This 2 and this 2 can cancel. So we're actually just left with x all over the square root of x squared plus 1. And you can put the square root back in the very last step. The biggest catch is when we go to do second derivative and third derivatives, you don't want to turn it back into this to do the second derivative. You will want to use x times x squared plus 1 to the negative a half and do product rule. You could do quotient rule if you really wanted to as well. It just depends on what you like better. So that's the derivative of x squared plus 1 to the half. And you have to do chain rule whenever you have something inside of an exponent. Okay? Next example. Example 2. Differentiate. Here's two different ones. Y equals sine x squared, and B, y equals sine squared x. Very different. The very first one, we have an x squared in the brackets. Let's pretend that's just an x for now, just like we pretended what was in the brackets before was just an x, right? If this was just sine x, what would the derivative be? Cos x, right? So if we took the derivative of just sine x, it would be cos x. So x in this case actually is x squared, so we have to write x squared, not just x. Okay? So we do just the same thing as we did before. If we did sine x, the derivative of that would be cos x. So sine x squared, the derivative is cos x squared. But I told you whenever you differentiate, you have to differentiate everything at some point. What have we not taken the derivative of? The x squared. So just like the bracket before, we had to times it by the derivative of what was inside the brackets. Same thing here. What's the derivative of x squared? 2x. And then we just write it at the front. So it's 2x cos x squared. This 2x cannot join the cos anywhere because you can't just put it inside with the cos, right? If you're trying to put something inside with a cos, that's an angle. You're doing cos of x squared. X squared is an angle of some sort, like 60 or 70. You can't just take some random number in front and put it in with the 60, right? If I asked you that, could you do that before? You gotta be like, no. But here you try and like put them together. You can't. If this was 20 cos 60, could I bring the 20 inside with the 60? No. So if this is 2x cos x squared, can I bring the 2x in with the x squared? No. Same thing. Now, somewhere along the line, someone thought this was prettier looking, sine squared x. And I've told you guys this in grade 12 when we were doing grade 12 that sine squared x is nicer looking. However, it makes people not realize in derivatives to do chain rule. What did I tell you before? What's sine squared x? How else could we write it? True, but how could we just rewrite sine squared x in a different way, like just sine squared x itself? Sine x squared. Sine squared x means I have a sine x times a sine x, correct? That's what sine squared x means. X squared means I have an x times an x. Y squared means I have a y times a y. Sine squared x means I have a sine times a sine, correct? So what I always hazard people to do whenever you're doing the derivative of a sine squared or a cos squared or whatever squared is to rewrite it as sine x squared, because that is what it is. And when you rewrite it like that, you notice, hey, chain rule. You have something inside a bracket to an exponent. And when you have something inside a bracket to an exponent, you have to do chain rule. So y prime equals, take your number, pretend this is an x squared, right? What do? Take the 2, drop it in front, and reduce it by 1. But you normally just have the x here, but the x in this case is sine. And you drop it by 1. Make sense? So it's just like if you had an x squared. Take the 2, drop it in front, rewrite the x, raise to the power of 1. So sine x squared is take the 2, drop it in front, rewrite the sine to the exponent 1. But what haven't I taken the derivative of? Sine. What's inside the bracket? So I have to multiply by the derivative of sine, which is cos. So it's just 2 sine x cos x. Very different. Example 3. Differentiate. Differentiate just means find the first derivative. Oh, that's x cubed minus 1 to the 100. So just pretend it's x to the 100. What would you do? Take the 100, drop it in front, rewrite the x to the exponent. What? 99. And then we have to multiply by the derivative of the brackets. then make the 3x squared join the 100 in front. So it's going to be 300x squared, x cubed minus 1 to the 99. You have to understand product rule, quotient rule, chain rule, trig derivatives, because next unit we use all those and then we go further, we solve so that we can draw graphs. Find f prime of x if f of x equals 1 over the cube root of x squared plus x plus 1. Please don't do quotient rule. It's 1 over something. If it's 1 over something, I always bring it up and then you can just do chain rule anyways, because you can just bring it up as a negative exponent, right? The very first thing you want to do with a radical, you guys, though, is always change it to a fractional exponent. So I'm going to do it in 2 steps. I'm going to go 1 over, and this would be x squared plus x plus 1 to the 3rd, correct? Because the exponent on it is 1, and then you bring underneath the index of 3. Now, you could do quotient rule if you wanted to, but because there's just a 1 at the top, a 1, a 2, a 7, whatever, as long as it's just a constant, a number at the top, always bring it up, because then you can just do chain rule. You don't even have to do product rule, right? So I'm going to bring it up, and I'm going to make it be x squared plus x plus 1 to the negative a 3rd. Then we just do our chain rule. F prime of x equals, take your exponent, drop it in front, negative 1/3. Rewrite it, x squared plus x plus 1. And technically with power rule, you're doing chain rule every time. It's just that the derivative of what's inside the brackets is 1, right? Like x, whatever. And then you subtract 1 from negative 1/3. Negative 1/3 minus 1 is negative 1/3 minus 3/3. And negative 1/3 minus 3/3 is negative 4/3. And then you times by the derivative of what's in the brackets, which is 2x plus 1. Now, anything with a negative exponent drops to the bottom. Anything on the bottom of the fraction, so the 3, drops to the bottom. So you're going to end up with negative 1, 2x plus 1 on top. And then the 3 on the bottom, and that fraction on the bottom too, to the positive exponent. And if we wanted to go one more step further, we can actually make that be x squared plus 1 to the 4 and the cube root of that. So you get negative 2x minus 1 over 3, and then the cube root of this all to the exponent 4. But like I said before, if you were going to go do the second derivative, you would never turn it into this and do the second derivative. You'd go right from here. Because when you differentiate, you never want it in a radical. You want it in a fractional exponent. Okay? Mm-hmm. If it's a multiple choice, you're going to stop when it matches. If it's a written response, as long as you simplify to here, I would be happy, but it's completely a preference thing. So most of the time, once you've simplified and moved all your positives or all your negative exponents down, and you've distributed into anything you can distribute, or GCF to anything you can GCF, then you'd be done. The bottom is just nicer, but It's total preference. For me, I'd be okay with the step above. Depends on what your prof would be okay with. And often they would be okay to hear, as long as they see you simplified. Most of the time they're pretty decent because everyone would kind of end up with a different version, right? All right. Example 5. Oh, good. It's off again. Find the derivative. Find the derivative of g of t, t minus 2 over 2t plus 1 to the 9. So this is going to be chain rule, but when you do the derivative of the inside, you're going to have to do quotient rule. I know, so much fun, right? Okay. G prime of t. This isn't as bad as it may feel right now. It's actually not that bad. So we treat what's inside the brackets like it's an x. So what do? We take the 9 down, we drop it in front, we rewrite the inside, raise it to the 8. Do you want to know how many of you, when you guys write the quiz, make me kind of cry inside? Because what you do is you take the exponent, you drop it in front, you do the derivative of the inside and write it to the 8. All the time. That happens all the time. Do not be that person, okay? So you just drop it down, rewrite it to the 8. What's the common error? You drop it down, do the derivative of what's inside, write it inside to the 8, and then you don't multiply by the derivative behind or what it is. You just kind of like want to do it all at once, okay? Problem with that, it gets you the wrong answer, so let's not do that way, okay? So drop the 9 in front, rewrite what's inside. You just rewrite it. Nothing fancy. Drop the exponent by 8 to the 8. Sorry, by 1 to the 8. Then you do the derivative of what's inside, which happens to be quotient rule. So it's going to be g, which is 2t plus 1, times f prime, which happens to be 1, because t minus 2 is 1, minus f, which is t minus 2, times the derivative of g, which is 2. All over 2t plus 1 squared. So this front part is just going to sit out in front. We're not going to do anything with it right now. We're just going to simplify the quotient rule. So it equals 9 t minus 2, 2t plus 1 to the 8. When you do distribute the 2t plus 1 into the 1, it just stays 2t plus 1. When you distribute the negative in, what I do myself is I combine the negative and the 2 together and then just distribute in negative 2. But if you distribute in the 2, you'll have to distribute the negative in after. Either way, as long as you get the right answer, it doesn't matter. So negative 2 times t is negative 2t. And negative 2 times negative 2 is positive 4. 2t plus 1 squared. The 2t and the 2t cancel. 2t and the negative 2t. So it equals 9 t minus 2, 2t plus 1 to the 8 times 5. over 2t plus 1 squared. Now, a lot of people will want to leave it here. Or they try and do some craziness with the 2t plus 1 and throw it in with the 8 somehow. But right now, if you look at it, the 8 is to both of these, correct? So your best thing to do is to write it separately to both of them, because then I can combine these after. So I get 9. No, separately, not as one. 9, and then t minus 2 to the 8 over 2t plus 1 to the 8 times 5 over 2t plus 1 squared. And this 9 is over a 1, technically, right? So if we multiply the tops all together, we'll get 9 times 2t minus 8, 2 minus t to the 8, times 5. And 9 and 5 can join each other. 9 times 5 is 45. So on the top, we get 45 t minus 2 to the 8. And on the bottom, what happens if we have common bases with exponents? What do you do with those exponents? You add them. So we're going to get 2t plus 1 to the 10. Now this chain rule is very, very, very important to learn, because if we have to do any type of rational embedded in it, and we want to graph it, this is one where you can actually solve it out not too badly next unit. All right, we have 3 more. Example 6. Differentiate y equals 2x plus 1 to the 5, x cubed minus x plus 1 to the 4. So this one, people go crazy. They like try and do chain rule first and do something crazy. We have 2 things multiplied together. When we have 2 things multiplied together, we have to do product rule. The last one we did chain rule first, then quotient rule, because we had our quotient rule embedded into the exponent, correct? The last one up here, if you didn't want to do chain rule into quotient rule, you guys, you could have just went t minus 2 to the 9, 2t plus 1 to the 9, and then done quotient rule with chain rule only used when you did the derivative of f and g. You could do that too. This is just faster. So this one, we have 2 things multiplied together. That means we do f, g. The only time chain rule comes into effect is when I need f prime and g prime in the product rule, okay? A lot of you guys try and do like chain rule randomly in here, embedded with some crazy product rule mess. Don't do that. If you have 2 things multiplied together, you will use product rule. Yes, you end up using chain rule when you need f prime and g prime, but that's it. You don't just do chain rule in the middle because you see something with an exponent outside a bracket, okay? So in order to do f and g, when you have to do product rule. Remember, it's f times g prime plus g times f prime, but because of quotient rule, we like writing it backwards because then it's the same. So g f prime plus f g prime. However, if you wrote f g prime plus g f prime, that's correct. That's how you'll see it in a textbook. That's how you'll see it on any type of formula sheet. Okay. So g is just g. G is x cubed minus x plus 1 to the 4. F prime is the derivative of f. And to get the derivative of f, we have to do chain rule because you have something inside a bracket to an exponent. So what's the derivative of f? Let's do it off to the side. It's going to be drop the 5 in front, rewrite what's inside the bracket. Don't change it, just rewrite it. To 1 less, which is 4. And then you multiply it by the derivative of what's in the brackets too. So you get 10, 2x plus 1 to the 4. I always do the derivative off to the side and then only put it in once it's simplified so you don't make oopsies. The less you have to do math altogether, the less chance of an oopsie. So f prime is times 10, 2x plus 1 to the 4, plus f, which is 2x plus 1 to the 5, derivative of the inside. You always have to do this, drop it down, rewrite it this, and then multiply by the derivative of the inside. That's where that 2 comes from. Then we have f times g prime. I have to ditch this because we have to keep writing. G prime, I'll do down here. G prime is just drop the 4 in front. Ooh. Drop the 4 in front, rewrite it. X cubed minus x plus 1. Drop the exponent by 1, 3. And then multiply the derivative of what's inside. So x cubed minus x plus 1, the derivative of that is 3x squared minus 1. And then I take that and make it join the front. So I get 12x squared minus 4 times x cubed minus x plus 1 to the 3. And I just rewrite that here. 12x squared minus 4 x cubed minus x plus 1 to the 3. Now what you have to notice is ultimately we have one term here and one term here, correct? So for you guys, we have one term here and one term here. When you use product rule with a chain rule in it, you have to say, if I had to expand this out, I would cry a lot. So if that is what your decision would be, if I have to expand this out, I would cry a lot. It's probably not the right decision. We don't want you crying. So we can say, hey, would there be something else that maybe could help? Whenever you use chain rule, you guys, you end up having one term where you end up keeping what's inside, right, to an exponent. So both terms, this blue term and this blue term, are going to have some terms that are the same that we can take out. So this one here has an x cubed minus x plus 1 to the 4, and this one has an x cubed minus x plus 1 to the 3. And I always told you have to take out the smaller one, right? Like when we took out fractions, we took out the smaller one, same thing here. So we can only take out what we have in both. So we have an x cubed minus x plus 1 to the 3 in both, right? Then this one has a 2x plus 1 to the 4, and this one has a 2x plus 1 to the 5. So I can take out a 2x plus 1 to the 4 out of both. And then the coefficients, sometimes you can't take anything common out of both of them, but let's just see. So this one, the ones that don't have random terms are the same. So 10 and 2x, or 12x squared minus 4. Can I take anything out of those? Yeah, what? A 2. And usually we write it out here. Then we write what's left over. So that's when I do the big square brackets. And my big square brackets, I always write big square brackets because I know I am not done until I can turn those big square brackets to round brackets. So the only time I can turn them into round brackets is if I have everything simplified inside those square brackets. So I take a 2 out of this first blue term, and I'm left with a 5, right? I take an x cubed minus x plus 1 to the 3 out of an x cubed minus x plus 1 to the 4, and I'm left with just one of these. So I just write it in brackets. And then I have a 2x plus 1 to the 4 I said I take out of both, and then it just goes away, right? They cancel. So of this first blue term, I'm only left with 5 x cubed minus x plus 1 after I've GCF'd all these out. Make sense? Then plus sign. Now I say I need to take all these 3 things I said I can take out of this term, second blue term. So if I take a 2 out, of 12x squared minus 4, I'm left with 6x squared minus 2, right? Then I take an x cubed minus x plus 1 to the 3 out of x cubed minus x plus 1 to the 3. So they just canceled off. And then a 2x plus 1 to the 4 I take out of a 2x plus 1 to the 5, and I'm left with 2x plus 1, just one of them. If you do the GCFing correctly, you should really only be left with one of these terms in one and one in the other, because when you do chain rule, you drop it down by one, correct? So one of them is going to have the full amount, and one of them is going to have one less. So when you take a GCF of them out, you should only have one left on one of the terms, if you're doing it correctly. Now, I still have square brackets because I need to distribute this. I know this still looks sad and makes you kind of want to cry as bad, but not as bad as crying up here. So we still have to distribute these out. So you get 2x cubed minus x plus 1 to the 3, 2x plus 1 to the 4, 5x cubed minus 5x plus 5, and to FOIL this, 6x times 2x, 6x squared times 2x squared is 12x cubed. 6x times 1 is 6x squared, sorry. Negative 2 times 2 is negative 4x minus 2. And then we collect like terms. Five x cubed, 12x cubed, 17x cubed, plus 6x squared, minus 5x minus 4x minus 9x, plus 5 minus 2 plus 3. This example will make the next example look like a cakewalk. Literally one step and then you're done it. So this one's way longer. It has trig in it, which would have maybe normally made you kind of want to cry a little, but now after you've done this one, you'd be like, oh, so easy. Because I've shown you guys these ones before. Example 7. Differentiate. Y equals e to the sine x. I have shown you chain rule with e, and I've shown you chain rule with bases already. I did it in the other unit, or other lesson, sorry. So this shouldn't be that bad. What do we do when we take the derivative of e? You take the derivative of the exponent, drop it in front, and rewrite it. Ln e. Derivative of the exponent, drop it in front, rewrite it, ln e. I feel like I have my song going. Derivative of the exponent, drop it in front, rewrite it, ln e. And ln e is just 1. If that happened to have been, I'll show you. So we'll do this one. Y prime, what's the derivative of sine? Cos x, e to the sine x, and you're done. Because it would be ln e behind it, but ln e is just 1. What happens if I gave you y equals 2 sine x? What's the only thing that would change? Exponent, take the derivative of it, drop it in front. So cos x, 2 sine x, exactly the same as the other one, except you'd end up with a ln 2 at the back, because ln 2 doesn't turn to 1 like ln e does. That's the only difference. And then this one is one that gets given a lot, so make sure you know how to do this one as well. These are all different kinds. And don't let it scare you, because it's not hard. f of x equals sine of cos of tan x. People freak out and they're like, how do I do product rule with 3 different things? You don't. You don't do product rule. There's one x. You do product rule when you have something x times something x. It says one x. It's full out chain rule. So if I give you guys full out chain rule. If I give you guys this, it's chain rule. If I gave you sine x times tan x, that's product rule. Both of them have an x, right? This is just embedded inside of here. There's one x, okay? So if I gave you sine x times tan x, that's product rule. When there's only one x, this is chain rule. So what do we do when we do chain rule of any sines or coses? If I gave you sine x, remember you told me that the derivative of that is cos x, correct? So we're going to pretend that this is sine x, okay? What would it be then? Cos x, x being this. So that's the first thing we're going to do. So sine of x, if we take the derivative of sine of x, it's cos of this. So cos of cos tan x. Then we have to do the derivative of what's inside the brackets, correct? So now I need to do the derivative of this. What's inside here? So the derivative of what's inside here is cos of x. What's the derivative of cos of x? Negative sine x. What's x in this case, though? Tan. So now I'm going to get times negative sine x, x being tan. Times, what do I have to do? The derivative of what's inside the brackets. What's the derivative of tan x? Secant squared x. The only thing I do at the very end of this is sometimes you'll have like a negative in here and a negative here and a negative here. Just multiply all your signs together. Because other than that, you can't make it any nicer, right? So this would be positive times a negative times a positive. So it would really just be negative. Often the secant comes to the front, but whatever. For ease, we won't write it. Cos tan x, because that's one term. It has one x. Sine of tan x. And that's one term. So multiplied by this term. Secant squared x. I'll give you your homework today, but you'll have some time tomorrow to work on it. But during scheduled help, you have no excuse to not have anything to do. So don't tell me you do.